This is a concept of finding perfect squares. We're going to start out with squares. If I look at x squared is a square. Notice that what you have are two x's. A pair of x's make it a square. If I take a look at x cubed is not a square, but does it contain a square? Yes, it's got a pair of x's, so it's a square with an x by itself. X to the fourth has two pair. X to the fourth is even, so it is a square, but you notice it's embedded, it's got two squares, namely x squared times x squared. That's going to be x to the fourth. So this is a square. Squares are pairs. They're pairs. Because a square is defined to be anything times itself. If I look at x to the fifth, there's a pair, and there's a lone x. So it's an x squared times an x squared times an x by itself. X squared times x squared, those are squares, so it's x to the fourth times x. So this is what I kind of want you to notice and to get out of this. If I'm looking for a square that's in a variable, right? The largest number divisible by 2 before 3 is 2. That's your square. Because 2 is divisible by 2. And then you've got 1 left over. The largest number divisible by 2 before 4 is 4 itself. It is a square. It's divisible by 2. 5. The largest number divisible by 2 before 5 is 4. So x to the fourth is your square. And x to the 1 is what's left over. So what our goal is going to be, and by the way, the hard part's going to be the numbers, is I want to take each expression and I want to break it into two pieces. One piece is going to be a perfect square. The other piece is going to be the leftover. So if I come back up here to x squared, if I were to try to break this into two pieces, this would be the square. This is going to be what's left. Well, I have an x squared. He's the square. There's nothing left. So he is a square. If I look at x cubed, the largest number divisible by 2 before 3 is an x squared. That's your square. I have how many x's? I have 3 x's. I have 1 left over. That's your square. X to the fourth, we found, is a square. X to the fifth, if I want to say the square, and what's left, the square in x to the fifth, well, the largest number divisible by 2 before 5 is 4. And how many x's did I have originally? 5. So how many's left? 1. In squares, there's only ever going to be 1 left over. Why? Because if you have 2, you got a square. If you have 3, it contains a square. So the largest left over with squares is 1. So if I want to take 32, I want to break 32 into the square and leftover. Well, I know the leftover in the variable is x because I only have 1 of them. Now this is how I handle the number. I want the largest square that's in 32. Now, if I take a look at my squares, here's my table of squares. 36 is bigger than 32. That ain't going to be it, right? I take 25. Does 25 divide 32? No. Does 16 divide 32? Yes. And I use my calculator if necessary. The largest square in 32 is 16. So I can write 32 as 16. That's the square. What's left is 2. If I multiply these two together, I should get 32x. Variables are the easy part. Numbers are the hard part. I'm looking for squares. Y to the 4th is a square. And you say, well, why is that? Because 4 is even. It's evenly divisible by 2. X cubed is not a square, but what's the square in x cubed? X squared, what's left over? X. Now I need to find the square that's in 32. 72. Or 72, I'm sorry. That's in 72. Well, here is 81, bigger. Does 64 divide 72? No. Does 49 divide 72? No. Does 36 divide 72? Yes. So the largest square is 36. And if I divide 72 by 36, I'll get 2. I always start with the biggest and work down. I don't work up because I won't get it all. Square. Now again, the variables are easy. The largest number divisible by 2 before 3 is 2. X squared, how many x's are left? 1. I have 3 of them. Y to the 8th is even, so he is already a square. Z to the 9th, what's the largest number divisible by 2 before 9? 8. So it's Z to the 8, how many is left over? 1. What's the square in 40? 4. Okay, take a look at it. 36, no. 25, no. 16 doesn't divide 40. 9 doesn't divide 40. So it's 4, and then what's the leftover? 10. Squares.